Okay, so this is graphing or solving, sorry, nonlinear inequalities. This is probably the most complex that you guys are going to see in this class. What we have here is we have a fraction, 5 over x minus 4 is greater than or equal to 3 over x minus 2. So the way that you want to solve this is you actually want to get 0 on one side of the inequality. So the first thing I'm going to do is I'm going to subtract the left side to the right side. That way we can have it greater than or equal to 0. And then we can use the inequality greater than or equal to 0, which essentially means positive, to help us graph this thing. So first step, I'm going to subtract this to the other side, essentially rewriting the problem so that it goes from this into 5 over x minus 4 minus 3 over x minus 2 is greater than or equal to 0. The second thing you want to do is you want to now take these two fractions and write them as a single fraction. But this does mean you're going to have to find a common denominator. Since they're already in their factored form, we're just going to multiply this one by x minus 2. So we're going to multiply the top and bottom by x minus 2. And that'll make the denominators the same. I'll now have x minus 4, x minus 2. And then I'll have to do the same thing on this one, except multiply by x minus 4. So I'll go ahead and distribute that. What we get is 5x minus 10 over x minus 4 times x minus 2. And then we're going to also want to do the same thing. We're going to multiply this fraction by x minus 4. And we'll multiply the top by x minus 4 as well. And then we'll have minus, and then we'll distribute 3x minus 12, 3x minus 12 over x minus 2 times x minus 4 is greater than or equal to 0. Now that we've got this set up, what we can do is we can collect like terms. So I'm going to take the negative sign right here, and I'm going to distribute it to the 3x and to the negative 12. So we'll get 5x minus 3x, which is 2x. So we now have 2x. And we'll have negative 10 minus negative 12, which is negative 10 plus 12. So we have 2x plus 2. So we have this new fraction, 2x plus 2, with x minus 2 as the denominator and x minus 4 as the denominator. This is all greater than or equal to 0. And now at this stage, we want to factor the top and factor the bottom. So we factor the top. This is going to give us 2 times x plus 1 over x minus 2 times x minus 4. Now I'm going to differentiate in the colors here because there's an important idea about the inequality, and that's the fact that the denominator is the restrictions, and the numerator is essentially the zeros. So in this problem here, the top is allowed to equal 0 because it says it can equal 0 right there, greater than or equal to 0. But then the denominator can never equal 0. Well, that's a mistake right there. That should say a 4. Sorry about that. So we're going to change that guy to a 4. Go back. Sorry. Give me a second. We'll change that guy into a 4. And then after you identify your restrictions, what you can do is you can identify the restrictions and your zeros. So I'm going to start my number line and start graphing this guy here. All right, so first thing we're going to do is we have a 0 at negative 1, and then we have a restriction at 2, and then a second restriction at 4. So I'm going to start by graphing those pieces right there. So negative 1, we'll go ahead and put that guy right there. 2, probably around there. And then 4 is probably going to be chilling right about there. Now the negative 1 is actually a 0, so I'm going to circle it. Oh, and then I'll circle this guy. And then I'll circle this guy. Now the negative 1 actually is a 0. You can equal 0 because it says you can. So we're going to shade that guy in. So we're going to shade that guy in. And then these two guys we're not going to shade in. So we're not going to shade in the 2 and the 4 because they're restrictions. They're things that can't occur. Now this separates our graph into 4 regions. Region 1 right here, region 2 here, region 3, and region 4. What we want to do is we want to pick values for each of those. So for this region, I'm going to just plug in negative 2. And for this region, I'll plug in 1. And for this region, we'll go ahead and plug in 3. And for this region, what we'll do is we'll plug in 5. Now, the fact that we got it greater than or equal to 0 means we don't need to verify what the value is. We just need to verify that it satisfies this. And this means positive. So as long as the result is positive, that's all I really care about. All right, so what does that mean? So I'll plug it in. So the 2 is always positive, so that doesn't really matter. Let's plug in negative 2. Negative 2 plus 1 is negative 1. So I get a negative 1 over negative 2 minus 2 is negative 4. So I'll get a negative 4 at the bottom down there. And then negative 2 and negative 4 is negative 6. Now, once again, there's a 2 out there, sorry. Once again, we don't care what the actual value is because we just need it to be positive. Well, if you multiply this out, a positive times a negative, that's going to be a negative. So we'll have a negative on the top divided by another negative times a negative, which actually is a positive. The result is that this guy here is negative, which means we don't want this region. This region is no good for us. It actually isn't going to work. Now what we'll do is we'll test this region here by plugging in 1. And this time, instead of actually plugging in the values for the numbers, I'm just going to do the signs. So we're going to have 1 plus 1, which is positive. So I'll have a positive on the top, divided by, and then when I plug in 1 here, I'll get a negative, negative 1, and over here I'll get a negative 3. So essentially I get a negative times a negative. Now if I multiply a positive divided by a negative times a negative, I'll get a positive, which tells me this region is perfect. We want this region. This region right here, that guy's going to work for us. Next, we're going to test 3. So when we plug in 3, we get a positive on the top. So we'll get a positive on the top over, and then we'll get 3 minus 2, which is 1, which is positive again. And then 3 minus 4 is negative 1, which is a negative right there. So we'll get a positive on the top and then a negative on the bottom, because a positive times a negative is a negative, which gives us a negative. And this is no bueno. We don't like that guy, so we're going to cross that guy out. Next, we're going to test our last region, region after 4. We're going to test 5. When we plug in 5, we get a positive, so we're going to get a positive on the top, over, we're going to get a positive 3, so positive on the bottom, times positive 1, another positive on the bottom. When you multiply all these things out, we get a positive, which is what we're looking for. So this region over here is going to be our solution. So we have 2 regions that we need to now identify. So what we're going to say is from negative 1 to 2, we have solutions. But we are allowed to include negative 1. So on the interval negative 1 to 2, where 2 is not included, but negative 1 is, those are all my solutions. And then I need to include this region over here. So I'm going to say starting at 4, but not including 4, and going all the way to infinity. Now we write a union symbol between the two, and this is our solution set. So we can say x is an element of the set negative 1, 2, where we include negative 1, but we don't include 2, union 4 to infinity. If you have any questions, please send me a text or an email.